Okay, this is a drawing, a sketch of the problem. We have here a boat um, and some water, the dock, a tower. Now, where the distance from the top of the tower to the sea level is given as 8.75 meters. And we're going to call that D sub V. That's the vertical distance. Right now, if the equipment is thrown at an angle theta with respect to the tower, it will travel in a parabolic arc until it hits the water. Okay, so there's a vertical component to that, and it's equal to the total velocity, which is I think it's 15 meters per second, times the cosine of the angle, 60 degrees, is 7.5 meters per second. It has a horizontal component, which in this case is V sub t times the sine of the angle. And you work that out, you'll come out with 12.99 meters per second. Now, what you have to realize is the time that it takes from when the equipment leaves the tower to hitting the water is the same as the time of the vertical component, the equipment going down through the vertical component down to the water. Okay, so I just briefly mentioned VT is 15 meters per second, the boat velocity 0.45 meters per second. So now there's a formula that says this distance dV, which we know, 8.75, is equal to the velocity, the vertical velocity times the time, plus 1/2 g, acceleration of gravity, times the time squared. So this can be rearranged into the quadratic equation, and you could solve this using the quadratic formula. And what you should get when you put all the relevant information is 0.775 seconds for the equipment to hit the water, or whether if it were a drop with the initial vertical velocity to hit that water. So now the distance that the boat travels in that time time t rather, is this distance right here. And that's the velocity of the boat times the time, which we just worked out. And it's 0.45 times 0.775 seconds. And you come up with 0.349 meters. The distance from the point of the equipment hitting the water to the dock is the horizontal velocity, which is this, times the time. And the horizontal velocity we already know is 12.99 times 0.775 is 10.1 meters. So the total distance that the boat should be, is equal to the sum of 0.349 plus 10.1, which rounds to 10.4 meters. I hope this helps. If you have any other questions, please make a comment. Thank you.